Dear students, in this session we'll learn about equations of motion. The first equation of motion is, of course, we have derived. Let me have a small diagram. It will make the things very, very clear. This is your time. This is your velocity. And what is interesting here is, if the object starts from here, you call it as A point. And this is O. And at this point, if it has initial velocity V0, and in a time interval, it travels a certain distance, call it as a B point. If this is a velocity, you call it as final velocity. Initial velocity, final velocity. And everything under this curve is taken as area under the curve. Everything under this curve is called area under the curve. It is called area under. Yes. This area under the curve gives us displacement. That displacement is taken as a notation x. I hope you remember in the last class we had a relation, this final velocity equal to initial velocity plus at. This is the first relation I had. Then I said this is an interesting relation. At the same time, we derived x equal to v0t plus half at square. This relation is an equation of motion. This is called second relation. At the same time, we know that x is written as displacement equal to average velocity into time. And this average velocity can be written as final velocity plus initial velocity divided by 2. Whereas this t is substituted in this fashion. This t is equal to, if I rearrange it, equation 1 gives me t equal to final velocity minus initial velocity. In the denominator, a comes. If this t is substituted in this relation, call it as equation 2, call it as some equation notation 3. If 3 is put here in wherever t is present, this equation reduces to final velocity minus initial velocity divided by a. And this whole x is here, x equal to, now it looks like v plus v0, v minus v0. It looks like a plus b minus a minus b. Whenever you have mathematical identity a plus b or a minus b, you can use a square minus b square identity. The same thing, denominator get 2a. So here it is final velocity square minus initial velocity square. I hope you can understand. This v plus v0 is an identity and v minus v0. So you can take it as treat as a plus b, a minus b. So I can simplify it as a square minus b square. Hence displacement becomes displacement equal to v square final velocity square minus initial velocity divided by 2a. Further simplification, if I take this side, this simple relation looks like very effective relation, 2ax, because this 2a is taken on the left hand side, which is equivalent to v square final velocity square minus initial velocity square. Further simplification, if I take only v square, like final velocity equal to initial velocity plus at, if I want to make it, so it reduces to, I can put it, or final velocity square as it is. This initial velocity is brought on the left hand side, it becomes initial velocity square plus 2ax. And this relation, I can call it as a next beautiful equation of motion. I can write it here. Final velocity square equal to initial velocity square plus 2 times acceleration into displacement. This is, call it as equation 4. So equation 1 is called equation of motion when uniform acceleration. Here, acceleration means acceleration is a constant. Velocity is changing. This is initial velocity. This is final velocity. Velocity is changing, but the slope of this curve remains constant, hence it's called uniform acceleration. Treating the object has initial velocity v naught, it attains final velocity in the time interval 0 to t, initial time 0, final time t. So the first equation, second equation, even you can call this the last equation, the three equations have been obtained. These equation 1, equation 2, equation 4 are called equations of motion. The next part is when t equal to 0, when time was 0, x we have taken it as x equal to 0. Instead of x equal to 0, position x equal to 0, if I take x equal to x naught, some initial position, then the equations of motion which we have derived, they just slightly modified. The modified forms are here. The first part, t equal to 0, x equal to 0. The equations of motion are final velocity equal to initial velocity plus acceleration into time. This was a condition. Next, displacement equal to initial velocity into time plus half at square. And the third one, final velocity square equal to initial velocity square plus 2 times acceleration into displacement. All these three relations were derived treating this condition. What is the condition? When time was 0, displacement was 0. Now, if time equal to 0, if I take initial time equal to 0, think this position or displacement equal to x naught. So what are the relation? Wherever x is present, you just make it x minus x naught. Let me do it. Final velocity equal to initial velocity plus at. No change here as it is. Second equation, now it is x. Wherever x is there, replace x with x minus x naught. It becomes x minus x naught. X minus x naught is equivalent to v0 t plus half at square. I hope you're getting a point. When time was 0, position was 0, so equation becomes like this. Now, if I take time equal to 0, position is x naught, some well-defined position. Now, wherever x is there, put x minus x naught. Simplification of this equation. This x minus x naught goes that side. So this relation becomes x equal to x naught goes that side, initial position, final position. This is called final position minus initial position, which is called displacement. So final position equal to initial position plus initial velocity into time plus half at square. Now this we notice now. This equation slightly modified, x as it is. So on the right hand side you have x naught, initial position was included. This is plus. Yes. Now when I go for this equation, again it is v square is equal to v naught square plus 2 times a initial position, final position minus initial position. This is again a modified form. So this relation 1, 2, and this one as it is, no issue. X equal to x naught was added and final velocity equal to initial velocity plus 2a, 2 as it is. Instead of x, it is final position minus initial position. This gets modified if x equal to x naught. This is a final standard relations. Now all the three equations of motion, final velocity equal to initial velocity plus at, displacement equation and final velocity, all the equations are obtained by the method of calculus. Equations of motion by the method of calculus. Calculus is a big area in which mathematics means calculus come under a mathematical discipline. So what is the mathematical discipline? Calculus. We are not going in detail. We'll apply some mathematical ideas to understand how my equations of motion are obtained. Of course, what is the method? I know that, we know that. Acceleration is defined as rate of change of velocity. It is called rate of change of velocity, dv by dt. This dv by dt, call it as equation 1. I can modify it. Or acceleration into dt is multiplied a A dt equal to dv. This equation I will integrating both sides. Integrating both sides. Integration is a process. So integration becomes integration of dv is equal to integration of a being a constant, I'll take out of the integration dt. Since v is a variable, time is a variable, time varies from 0 to t. T1 equal to 0, t2 equal to t. Velocity also initial velocity, final velocity. Initial velocity because velocity is variable. When I integrate it, the result of this integration gives me the next step. So I need to have velocity, lower, it is called lower value, it is called upper value, hence I can call lower limit, upper limit. So lower limit is initial velocity, upper limit is final velocity. Now acceleration is a constant, like velocity, if integration and differentiation are opposite, hence t becomes here, you have a lower limit, you have upper limit. Once I simplify further, this step takes me to the next step. What is the next step? This value I need to put into this relation, final velocity minus initial velocity. So it moves from here, final velocity minus initial velocity. So whenever you have a velocity and you have a lower limit, upper limit, first put upper limit, subtract into, yes, lower limit, upper limit minus lower limit, which is equivalent to A. Again, time t minus 0 because upper limit is t, lower limit is 0. So inside bracket, it is t minus 0. So once you simplify, it becomes final velocity minus initial velocity, which is equal to A into t. A into 0 is 0. So after simplifying the final step, or final velocity is equal to initial velocity plus AT. This is called, by the method of calculus, I obtained equation 1. Equation of motion, V equal to V naught plus AT. By the method of calculus, start with acceleration, then separate the variables, time on one side, velocity on one side, integrate both sides. Since velocity varies from initial velocity to final velocity, initial velocity, final velocity, the initial time is 0, final time is 3, time varies from 0 to t. So acceleration is a constant because I said the slope is constant. When the quantity is not varying, this is a constant, this is variable, take the variable outside, a variable inside and constant outside, then integrate it. After integration, integration of dv gives me v, lower limit, upper limit, a, lower limit, upper limit, then upper limit minus lower limit equal to a, upper limit minus lower limit. Do the mathematics, this gives us equation of motion, final velocity equal to initial velocity plus at. Like final velocity equal to initial velocity plus at, let me obtain by the method of calculus the displacement equation. It is x equal to x naught, final displacement means final position equal to initial position plus velocity into time plus half at square. The first guiding relation is, we know that, yes, instantaneous velocity or final velocity is nothing but dx upon dt. This is called rate of change of displacement, velocity equal to displacement upon time. So call it as equation 1. Now rearrangement will give you velocity into time equal to dx. This is the equation guiding relation. Now integrate both sides. Integrating both sides. Yes, then integration of dx, which is equal to integration of v dt. This v is replaced with equation of motion. What is the equation of motion? Final velocity plus at. So the lower limit and upper limit are here. Initial position, final position dx, which is equal to this relation. This v is replaced with final velocity plus, sorry, initial velocity plus at. Then you have a dt. This is a relation. Now, since it is only one entity, it has first part and second part, we simplify it. How to simplify it? Let me write it here. This becomes x naught, initial velocity, sorry, initial position, final position, dx. On the right hand side, I can have two relationships. Let me write it here. This velocity into time. This is velocity v0 into dt. Here the variable is time, here the variable is x, plus again integration at dt. Again the variable is time here, where initial velocity and acceleration are constant, they will be taken outside and your limits goes in this way. This becomes whole simplification, gives me again x naught x dx. This becomes velocity outside because it's being a constant. Constant are taken outside dt. Since it's only one variable, the lower limit is 0, upper limit is t. This is lower limit, upper limit. Initial velocity, this is fixed, this is also fixed, taken. Plus acceleration is constant, acceleration is taken outside the integration. This symbol is called integration symbol. I hope you can easily understand. Now what are the time variables? Time variables again 0 to t, left with t dt, left with t dt. Now this integration of this gives me very simple relation. It becomes x naught x. This first part is over. Now v naught as it is, again dt means t 0 to t plus acceleration. This I am talking now. This whole is a different entity, plus a integration t dt. Whenever you have a t dt, it becomes t square divided by 2, yes, lower limit, upper limit. This is additional mathematics. So you have a integration of x naught x dx, integration of dx is x, lower limit, upper limit, lower limit, upper limit. Integration of dt like x, it is v naught as it is, integration of dt is t, lower limit, upper limit. When it comes a is here, but integration of 0 to t dt, this is additional term. Whenever you have a t, it becomes t square upon 2. The final simplification gives you a simple relation. Let me remove it. Yes. The final equation, this equation from here, I will be having a final relation. X, it is lower limit, upper limit. On the right side, you have initial velocity, time, lower limit 0, time. This part over. The first, a acceleration, inside the bracket you have t square become 2 comes outside, this t square remains. Let me write it once again. It is t square, lower limit 0, upper limit t. Why I have taken 2 outside? Because 2 is a number. Anything constant, take it outside the bracket. Now you substitute. Yes. The substitution becomes this x upper limit, lower limit. X minus x naught. First part over. Second, initial velocity as it is. Now again, upper limit is t minus 0. Yes, over. Plus a by 2. Again a by 2. Again t square, upper limit is t square minus 0. Means wherever t is there, I substitute it here. When you simplify it, it becomes x minus x naught is equal to, it becomes initial velocity into time, plus it becomes a by 2, this t square. When you cross check everything, this relation is very simple. X minus x naught can be taken outside on the right hand side. It becomes final position is equal to initial position, same equation, or plus initial velocity into time plus half, you can write it is square. I repeat, we started with a velocity. Velocity means instantaneous velocity equal to dx upon dt. It is called change in displacement with time or rate of change of displacement. Rearrange it. V dt equal to dx. Then integrate both sides. Integration of dx, integration of v dt. This v is replaced with equation of motion. What is equation of motion? V naught plus at. Now you have only one variable. You have variable here and here. Again v naught. Separate it. This is first part. This is second part. Integrate first part, integrate second part. First part integration here, second part integration here. When I cross check the integration, v naught is a constant, take it outside. A is a constant, take it outside. Then go on integrating it. When you integrate, you will end up with x equal to x naught plus v0t plus half at square, which is an equation of motion. It is called final position equal to initial position, final position equal to initial position plus initial velocity into time plus half at square. Thank you.